Hello my dear friends, in this video we are going to learn concept of principle of mathematical induction. So mathematical induction is basically about, for example, if you have this series 1 plus or 2 plus or dot 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 n, and this is equals to n into n plus 1 divided by 2. So this formula you had learned in your chapter of sequence and series. So by using the principle of mathematical induction, we have to prove this formula. So principle of mathematical induction says that the continuation of process. What is meant by continuation of process? It says that, for example, if 1 is equal to 1, and if you are taking some numbers, for example 1 plus 2 plus 3 plus 4, and so here we have 4 natural numbers. So we will put here 4 into 4 plus 1 divided by 2. So we will get this as 4 into 4 plus 1 is 5 and divided by 2. So 2 ones are 2, and here we will get 2. And so what left over here? 2 into 5 is 10. So summation of this 4 numbers, 4 natural numbers, what we got? We got as 10. So this formula is true for this one number, and it is also true for this 4 numbers, and it will be true for all the n natural numbers. So we have to prove this continuation process only if it will be true for one number, and if it will be true for this k numbers. And what is our k here? K is here our 4, and if it is also true for k is equal to 4 plus 1, means if it is true for 5 natural numbers, then we can prove that it will be always true that all the natural numbers, if we add them up, the formula will be this. So let's start that what is the principle of mathematical induction. So according to mathematical induction, first we consider a base step. So base step says that the statement that we have written here will be our P of n, that is it is a proposition, and a proposition basically means it is our mathematical statement, or you can say it as mathematical statement. So what was our mathematical statement? It was 1 plus 2 plus dot 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 n is equals to n into n plus 1 divided by 2. So we have to prove this. So we will name this our statement as P of n, where we have proposition in terms of n. So what is our n? N is nothing but that belongs to natural numbers. Okay, so we have n natural numbers. So since you know what is a natural number that starts from 1 and goes till infinity, you had learned this in the previous classes. So how we can prove this by induction? So induction, first it have base step. So in the base step we consider P of 1 is always true. What it means? We consider that the P of 1 is always true. What is this? It means that if we have one natural number 1, and if we put it into the formula, our formula was n into n plus 1 divided by 2. So we have one natural number, so we will put in formula as 1, and if we solve this, then this is our left hand side and this is our right hand side. So we can see that this is 1 plus 1 is 2, and in denominator you have 2, so this gets cancelled, and we got in right hand side we got 1, and in the left hand side there was 1 already. So we came to know that 1 is equal to 1. So everyone knows that 1 is equal to 1. Yeah, so this is the base step, that is a P of 1 is always true. This is our base step. P of 1 means if we have one natural number, so this formula obviously will be true for this one natural number. Now there is another step, that is inductive step. In the inductive step, this is our inductive step. In the inductive step, we put n is equal to k, and we assume that P of k is true. So we assume that P of k is true. What it means? P of k is true. What it means? It means that we assume we assume that P of k is true. P of k is true. It means that 1 plus 2 plus dot 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 k is equals to k into k plus 1 divided by 2. So it means this. We assume this and we prove that we have to prove it is true for P of k plus 1 is true. We have to prove this. So how we will prove? We have to prove P of k plus 1 is true. So we will prove this using so what will be our mathematical statement in terms of k plus 1? It will be like this 1 plus 2 plus 2 dot 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 k, and then it will be having k plus 1, and we have to prove that this is equals to k plus 1 multiplied by k plus 1 plus 1 divided by 2. It is nothing but we have substituted k plus 1 in terms instead of n, since we had that formula n into n plus 1 divided by 2. So we have to prove that left hand side is equal to right hand side. So we can prove this. Okay, let's prove that left hand side is equal to right hand side. So how we can prove that? So on the left hand side we had the terms 1 plus 2 plus dot 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 k plus k plus 1, and on the right hand side we had the terms, sorry, we had formula k plus 1 into k plus 2 divided by 2. So this you know that P of k is true, so we can write it as k into k plus 1 divided by 2. You know that formula, no, in previous we saw. So this will be plus k plus 1. So left hand side comes like this, so we will take k plus 1 common. So we will be left with this k by 2 plus 1. So this will be equal to k plus 1 divided by k plus 2 divided by 2. So we can write it as k plus 1 into k plus 2 divided by 2. So this is what our right hand side. So we had proved that left hand side is equal to right hand side. So we can say that P of k plus 1 is also true. We had assumed that P of k is true. We had assumed this statement that P of k is true. So we had proved that P of k plus 1 is also true. So we can say that P of n is true for all natural numbers and belongs to natural numbers. So this is basically the principle of mathematical induction, and you can have this real life example in your cupboard also, since for example if you have arranged some cards like this but in a sequential order of same distance, then you know that domino effect. So what is a domino effect? If you put pressure on this slide, then if it falls apart, then it will make this slide also falls, then next slide also falls, then next slide also falls. So in this way, this is what a domino effect. So let it be n is equal to k. So what is the process of induction is that this is your n is equal to 1. So you had pushed a pressure. So for n is equal to 1, it will be always true. You know that. But if this is your n is equal to k, okay. So if a disturbance comes at here, so it is obviously possible that it will become a disturbance will also come here. That is your n is equal to k plus 1. So if it comes at if we had proved that it comes at n is equal to k plus 1, then we can say that all the tiles will fall apart. That is, all your cards will fall apart. This was what your domino effect.